welcome to PTC AVIATION Academy, and this is Captain Lakshmi Mohan. So today we are going to talk about a topic called as stall. Okay, stall in simple terms is known as the loss of lift. When the wing cannot produce, it's a condition where the wing cannot produce any more lift, is called as stall. So today we won't dwell deep into stalls. Today we are going to explain certain basic terminologies that is associated with stall, and which I'll be referring to quite often in my next video about stall. So first of all, let's take our aerofoil. Now aerofoil is basically, let's say, okay, before we get into aerofoil, let's say this globe here is a sphere, right? So if you chop this sphere into two parts, you're going to get two hemispheres. So with this two hemisphere, you get a circle as a plane. So basically, if you cut a sphere into two halves, you get this plane as a circle. Similarly, a three-dimensional three-dimensional wing, if you cut into a cross section, that cross section is called as an aerofoil. Okay, now coming into the terminology, in an aerofoil, there is a leading edge, which is the front part of the aerofoil, and trailing edge, which is the back part of the aerofoil. Now, a line, a straight line that is connecting the leading and trailing edge in an aerofoil is called as a chord line. Okay, as you can see, this chord line is not, it doesn't go through the aerofoil. It is just, if you see over here, it is cutting it a little bit over here, that is, it is coming outside of the aerofoil itself. But if you see the blue color line here, which is a camber line is also a line joining between the leading and trailing edge of the aerofoil. But the camber line, if you see, is distant from the upper and lower surface of the wing. So a camber line is a line joining leading and trailing edge, which is equidistant from upper and lower surface, and your chord line is just a straight line that is joining the leading edge and trailing edge of the aircraft. So wherever the distance between camber line and chord line is maximum, that is the maximum thickness, that is the position where you have the maximum thickness of an aerofoil. Okay, so this is basically your certain terminology associated with your aerofoil. Next, moving on to your relative airflow. Now, relative airflow or relative wind is basically the wind that is opposite to your flight path. So whichever direction the flight is going, whether it's climbing or descending, I've also mentioned this in a previous video, that it is opposite to the flight path. So there is three requirements for it to become a relative airflow. That is, number one, it has to be uninterrupted by the presence of aircraft. That is, it's a free flow of air which is uninterrupted by the aircraft. Then the second thing is that it has to have the same magnitude of the aircraft's true airspeed. And the third condition is that it has to be in the opposite direction of the flight path. So out of these two conditions can be easily met, but the third one, that it's the free stream airflow which is not affected by the aircraft, is kind of impossible. So what we have is that we have an effective airflow. Because these three conditions, out of these three conditions, one cannot be met, you have something called as effective airflow. So these are the two airflows that is airflow terminology associated with stall. Now the third one is the force, pressure gradient force. Pressure gradient force is the force that makes a fluid move from high pressure area to low pressure area. Fluid always moves from high pressure to low pressure, and when it is forced to move from low pressure area to high pressure area, that is called as adverse pressure gradient. Alright, so this is these are some of the forces that is associated with the airflow around the wing. Next is the flow of air around the wing itself. There are different types of flow around the wing. There are two different types, that is laminar flow and turbulent flow. Laminar flow is nothing but when all the molecules of the air is flowing in a straight line, is going in a straight line without intersecting each other. It is called as a laminar flow. But turbulent flow, on the other hand, is the flow that happens when there is any sort of, especially when there is adverse pressure gradient, which is forcing the air from low pressure to go to high pressure. What happens is that turbulent airflow is created. Turbulent airflow will be interjected. It is not going in a straight line. It is going in multiple directions and interrupting each other. each layer, I mean. Okay, so that is basically your laminar flow and turbulent flow. Now certain points that is there over the surface of the aerofoil. Stagnation point. Stagnation point is that point where the air splits to go to the upper surface of the wing and the lower surface of the wing. The point where it for momentarily stands still and then splits apart is called as your stagnation point, and usually the pressure around stagnation point is a little higher compared to the ambient pressure. Okay, so in this picture you can see the low angle of attack stagnation point, and the stagnation point moves a little downwards in a higher angle of attack. This is an important point. Remember this for the next video. I'll explain to you why it is important that stagnation point is moving downwards. Next we have transition point. Transition point is that point where the airflow from laminar becomes turbulent. Okay, and then we have separation point where the turbulent airflow separates itself from the wing surface itself. That's called as your separation point. Next is coefficient of lift. Now all these coming together, the aerofoil shape, the aerofoil size, the aerofoil's aspect ratio, everything come together along with the different flow, stagnation point, everything together makes the coefficient of lift. Briefly put, coefficient of lift is nothing but lift pressure divided by dynamic pressure. Now lift pressure is the pressure differential between upper and lower surface of the wing, and dynamic pressure is the pressure created because of the motion of the air, or it is mainly experienced on the leading surface of the aircraft. Okay, so this is your coefficient of lift. And so this is some terminologies associated with stall, and in the next video I will explain these terminologies and how it is associated with stall, along with some factors that is affecting stall, and also how stall recovery happens. Okay, that's it for today's video. I hope you have got some terminologies right for your next video. Hope to see you soon in the next video explaining stall, and you all have a good day.